All right, here is the last video for test 3A review. My first question here, 15, says if negative 1, 5, so here's negative 1, say way up here is 5. Let's make it more like this, a little bit more accurate. This is on my circle, and we want to know the 6 trig values for this function here. So here we go. This is the point negative 1, 5. Remember, the trig functions always go off of a theta as it goes from this line here down to the x-axis. Always from the line to the x-axis, that's your theta. If this point is negative 1, 5, I know the distance on the x-axis is negative 1. The distance on my y-axis is 5. Obviously, this is not drawing a scale, but we get the idea. If we wanted to find the radius for this one, how would we find the radius? Hopefully you said use the Pythagorean theorem. So negative 1 squared plus 5 squared is equal to my radius squared. That's 1 plus 25. So r is equal to the square root of 26. So is this point on my unit circle? It is not, because my radius is not 1. All right, so for sine theta, that's going to be opposite over hypotenuse, or 5 over the square root of 26. Rationalizing the denominator, that's 5 times the square root of 26 over 26. Taking the reciprocal of this guy to find cosecant theta, I get the square root of 26 over 5. In other words, I took this guy and I flipped it. Second function is cosine theta. Cosine theta is now adjacent over hypotenuse, or negative 1 over the square root of 26. Rationalizing that denominator, I get negative square root of 26 divided by 26. Finding the reciprocal of this to find secant theta, that would be square root of 26 over negative 1, or negative square root of 26. And then tangent theta and cosine theta are a little nicer, no square roots here. So tangent theta is opposite over adjacent, 5 over negative 1, or negative 5. Cotangent theta is the inverse of this guy, so negative 1 over 5. All right, number 16 says sketch the angle theta equals 300 degrees and find its reference angle. So here we go. This is 0 degrees, 90, 180. Hopefully you're not having flashbacks to your recent quiz. 300 degrees is going to be between 0 and 270. Here we go. This angle here is 300. We want to find our reference angle. Our reference angle always goes from the line we drew for our angle to the x-axis, never to the y-axis, always to the x-axis. So what are we going to do to find this particular reference angle? Well, I know it's 2 pi if I go all the way around, so I'm going to take 2 pi. Oh, not 2 pi, we're talking about degrees here, Ms. Harris. So we know it's 360 to go all the way around the circle. I'm going to take 360, I'm going to subtract off 300, and my reference angle is 60 degrees. Depending on what your quadrant is, sometimes you've got an angle and you're trying to find out, well, I know it's 180. Nah, I shouldn't mess it up. That's how you'd find this particular reference angle. If you have questions about this, try to send me an email and I'll help you out with the other quadrants if you have something from the homework. All right, here's one that's in radians, maybe. Oh, this one doesn't help too much either. Negative pi over 3, that's going in a clockwise fashion. Pi over 3 is just 1/3 of pi. So this is negative pi over 3. Again, our reference angle is always from the line here back to the x-axis. So I'm always worried about this angle towards the x-axis, never towards the y, always towards the x. And I know my reference angle is always going to be positive. So for this guy here, I know that this measure is pi over 3 because this is negative pi over 3. So the positive version is just going to be pi over 3. So my reference angle is pi over 3. But if I needed a mathematical equation, I would probably say, what is 2 pi? No. I think that's just the best way to think about it is if this guy is negative pi over 3, the positive version of that is still, like, we know the measure is pi over 3. It's just your reference angle is always going to be positive because your reference angle is always found in the first quadrant here. So what this is saying is, if I wanted to know what this point is, I'm going to go to pi over 3 up here in the first quadrant. I'm going to find its coordinates, which we know this from our quiz, right? What is the coordinates of pi over 3? That would be the square root of 3. Nope. That would be 1/2. And then square root of 3 over 2. So remember when we were building our unit circle, we said, okay, well this is the same thing as here because these angle measures are the same, except for now down here, I know I'm in the fourth quadrant, so I know my x is positive, my y is negative. So that's what we're using that reference angle for, and how I explained it in class, but we did it over 3 or 4 days, so I'm not sure if you saw the connection. So basically the reference angle is you draw your regular angle, which was this guy, and then you're asking yourself, what's the positive angle from that line to the x-axis? Hopefully that makes sense. If you still have questions, please come find me. You do have a question on your test over that. All right, find the exact value of cosecant 90. So 90 degrees is this angle here. This point up here on our unit circle is 0, 1. Cosecant is 1 over sine. And so that's going to be 1 over my y value. Remember, sine of an angle is y, is the y coordinate. Cosine of that angle is the x coordinate there. So my y coordinate at this angle is 1. So this would be 1 over 1. Sorry, not 1 over y, 1 over 1. So cosecant 90 degrees is 1 over 1, which is 1. All right, find the exact value of cosine 3 pi over 2. 3 pi over 2 is this guy here. Its coordinates are 0, negative 1. For cosine, we're looking for the x value. The x value at 3 pi over 2 is 0. So the answer here is 0. You will have, I think, at least one of these, if not 2 on your test. So make sure you can just pop those off real quick. Save you some time. All right, number 20, I actually typed it in wrong, but that's okay. It's still the same idea. The angle made by the swing of a pendulum and its vertical resting position. So think of a clock. It's got this little pendulum at the bottom of it, right? And it's swinging back and forth, right? And its resting position, so the angle that it makes from this being my resting position, back and forth, can be written by theta is equal to cosine pi t. It was supposed to be 3 cosine pi t, but that's okay. It says, what is the angle made by the pendulum after 6 seconds? So all that means is you're going to plug 6 in for t. Theta is equal to cosine 6t. And cosine of 6t, so here's my circle, right? This would be the point 0 pi, or if I go all the way around one time, it's also the point for 2 pi, go around one more time, 4 pi, go around one more time, 6 pi. So this is my point for 6 pi. We know this point is 1, 0. Cosine at this point is my x value, so cosine, the angle there would be 1, where 1 is measured in radians. All right, so that's number 20. If you have questions about this last one, don't worry too much. It's not really on your test. So I would not stress that one at all. Please feel free to email me if you have questions. I will try to stay close to my email tonight to answer anything you got. If not, come see me tomorrow during Power Hour.